Myopia.
So
Myopia.
the eyeball of a person has become slightly larger, means it is indicating that a person is suffering with a defect called as short-sightedness, or we will say nearsightedness, or we can say it is called as myopic eye. So now in myopic eye, the image will form in front of the retina because of high converging power, means the lens size is thicker or thinner. Everybody, lens size is
Thicker.
thicker, means focal length is not decreased. So sorry, focal length is not increased, so that the power is not decreased. So in this case, ciliary muscles are in what state? Anybody? Ciliary muscles.
Contraction.
Contracted state. So when they are in contraction, so that the lens is thicker, so that the power of the lens is more, because focal length is not increased. So that is the reason it is, or else maybe it is slightly larger than, even though the lens is working properly, but the eyeball is too larger, so that the image will form in front of the retina. So that is why, to decrease the power, what kind of lens they are asking here. So what kind of lens we'll use here to correct this defect of vision? Everybody? To decrease the power,
Concave lens.
we will use concave lens, because concave lens, they are, what is that lens called as? They are the
Diverging.
diverging lens, so that it will decrease the power. So that is what you have to remember. So how many more question it is? One. So now next question is the most important question, which you all will experience surely, something new, but question is a very easy one. So let us read the question very carefully. Now later only we'll answer it. So all of you observe very carefully here. It is having a two questions. First one, the images formed by an ordinary convex lens suffer from a defect called as chromatic defect. So till now you might be not hear this defect. What is this defect called as? So I will explain you. So observe very carefully what they are saying, that the images formed by an ordinary convex lens suffers from a defect called as chromatic defect, which leads to false colored edges in the images. This happens because light rays of different colors bend differently as they enter and leave the lens. So that is what they are saying. So now here the question is, if a parallel white light beam passes through this convex lens, the light of which color, means among violet to red in the spectrum, will converge at a point closest to the lens and justify your answer they are asking. So observe very carefully. First of all, you have to make it a new thing here called as chromatic defect. So what do you mean by this chromatic defect means? So basically, we all people knows that they are saying that what is the lens, guys? What is the lens they are saying? Please respond. What is the lens they are saying? Convex lens. So we all knows that convex lens means converging lens or diverging lens. All of you? Yes, please. Converging lens. So if I have taken basically a white light or a parallel beam of light, so you all should tell. So if I have taken a white light or a parallel beam of light, let me take, this is called as a line which is passing through the optical center. What is that called as? Everyone, you should say respond. It's called as principal axis. Is it
principal axis?
Yes. So now, if you have to observe very carefully, if I have taken basically in the general case a parallel beam of light, let me take like this. Now you tell me, this all the light after hitting the lens, they all will be the light which is passing parallel to the principal axis. They will go through the what, guys? Anybody?
Focus.
Go through the focus. So that is what we people have studied. So now in this case, lens is perfectly forming the image. So we don't have any objection. Now, what is chromatic defect means? So imagine that a white light is coming. So as we know, white light means is combination of how many colors? Everybody?
7 colors.
7 colors.
Now, whatever the light is coming, definitely it is converging. The lens is perfectly working. It is converging the image at the one point only. But it is suffering a defect called as chromatic defect means, remember, the lens failed to converge all the colors of light at the same point. That is the defect called as chromatic defect. A failure of a lens to focus all colors to the same point. Anybody is having any doubt, you ask me. For example, let me take, this is what my white color light is not visible. So that is why I am representing with the one red color. So, okay. So the others any contrasting color I will take. Just a minute. Like these questions will come, you'll feel entirely new things. So they're asking, it's not the new thing, just they're merging the concept of, observe very carefully, dispersion of light, you know that correct guys, from the prism. Do you remember that? Dispersion of light. So dispersion of light, they're just applying the concept to this lens. That's all it is, nothing is there. Because dispersion of light through a transparent prism. Now here transparent lens. So let me take, observe here very carefully. This is considered as a white light. Kindly everybody, because white light cannot be visible. So I'm considering this is what it is actually, white light. Do you understand? Now, what will happen means, what do you mean by chromatic defect? What I'm saying, chromatic defect means, yes, please. All the colors of light cannot be focused at the same point. So now, as we know, if you have taken the rainbow, so which color is up and which color is down? We all know that dispersion of light through the prism. Yes, please. White color will form. So which will be in up, which will be in down? You also tell me.
Red will be in up.
Red will be in up, and next.
Violet.
Violet will be in down. The same thing will happen here. So different colors will be converging at the different points. So this is violet color and this is the red color. Now the same white light which is passing from the bottom. So reverse it. Reverse the prism. Now what will happen? Anybody? Now again they will be converging. They will be focusing at the different points. Now who will be red and who will be violet? These three. Anyone? This will be the red. Understand? And this will be the violet. Middle, all the colors will be there. So this is how it will happen. See that all the colors should be focused at the same point. That is what a lens is perfectly working. But due to a defect called as chromatic defect, means, please note down everybody, chromatic defect, a failure of a lens to focus all the colors to the same point. A failure of a lens to focus all colors to the same point. So please make it everyone clear. Till here any doubt anybody can ask. And you understand the question now? First half question you understand or not? Yes, everybody? Yes. Now observe, it will make it. Now they are asking, this happens because light rays of different colors bend differently as they enter and leave the lens. So that is, we all knows that. Now tell me, from the dispersion of light, which is having more refractive index and which is having high refractive index, light, all the colors, 7 colors. Think very carefully, wisely, and tell me. So as we all knows that, who will travel faster and who will travel slower, who will bend more, who will bend less, means who is having most refractive index, who is having less refractive index. Anyone, please? I'm asking you the questions. Observe and tell me. Kevin, Helmukil, girls, who is having more refractive index, who is having less refractive index? Yes, Mukesh is saying red is least, and Rohit is also saying violet is maximum. Asita is also saying violet is maximum. Maximum who, minimum whom? Open, speak your mouth. As we all knows that refractive index is more, bending is more or less. Everybody. Yes, please. What is happening? Everybody is charting only, ready to chart, not to communicate. Then what else need? I don't know. So as we know that
violet has greater refractive.
because of maximum speed, violet is maximum deviation because of minimum speed. So if I consider the colors, remember refractive index. Now I am saying red to violet with GR, refractive index is keep on increasing. When we are going down, refractive index will increases. So now tell me at least who is having greater refractive index? Yes, violet. So because it will bend the most after refraction. Do you understand it? So who will bend most after refraction? Everybody, violet only, because of minimum wavelength, understanding, and minimum speed. Now the question, if a parallel white light beam passes through a convex lens in the same way, observe very carefully, the light of which color among violet to red in the spectrum, middle colors and all doesn't matter for us, violet and red only you see, will converge at a point closest to the lens. Check it and tell me who is converging closest to the lens, red color or violet color. Picture you see and tell me. Yes,
Violet.
all the answers should be responded. Every mouth should be, at least mind you have to. Which is converging closest to the lens? Check it, Elmukil. Violet. That is what I am saying. Closest to the lens, converging means bending. Understanding? So you can see here, which color is closest to bending? Girls? Violet.
Violet.
So answer is violet. Please. Such a really that you know I am really not predicted like these questions will come. So what is the answer now? All of you, violet is your answer. You can see here how it is bending. So it's very just a normal question only it is. But instead of a prism, they kept a lens, nothing and nothing else. So now answer. What is that? Because it will bend the most after refraction. Understanding? That is the reason. Or else justify your answer. Two reasons are there. One is you write. What is the first answer? Anybody? Because it will bend the most after refraction. After refraction. Why, guys? What is the reason behind? It will be closest to the lens. Because what is the reason behind? Because of
Less speed and less
wavelength. Minimum wavelength, minimum speed, and what is having maximum?
maximum deviation.
Understanding? That is only called as converging at the closest to the lens. Okay, so this is having the violet color light. Okay, because if you take this one, refractive index is maximum for violet light only for this class. So that is what you have to remember because of minimum speed. Okay, make it everyone. Write the answer. First justify your answer. One reason is because it will bend the most after refraction. These are all the reasons you can write because of minimum wavelength, minimum speed, maximum bending. because it will bend the most after refraction. And glass has the highest refractive index for violet color light. Glass has the highest refractive index for violet color light. What is it? Why? What is the meaning of this statement? Anybody can tell? I want at least one or two you can answer. Glass has highest refractive index for the violet color light. What does it mean? Anybody? Please. Suppose if I have taken a prism or a lens or whatever it is, now I will pass the red color, I will pass the blue color, I will pass the yellow color, I will pass the violet color, I will pass the green color. Now, whatever it is, WebGR, you take from WebGR. Now tell me, in which case the same lens will show the greater refractive index? Anybody? Greater refractive index. Yes, please. Greater refractive index. When is the greater refractive index is? Refractive index is maximum. Anybody can tell? Refractive index is maximum means something will be minimum. Anyone?
Speed.
Yes. Very good. Speed will be minimum. So for in the given colors of light, which will be having refractive index is maximum? Anyone?
Violet.
Understand? Because of what is the reason? What is the reason?
Minimum.
Speed is minimum. Mr. Rudreshwar, do you understand this one? Speed is minimum. So that in which colors of light glass is having maximum refractive index?
Violet.
Violet color. Basically, we know that what is the refractive index of glass? Anyone? Refractive index of glass is what? 1.53, I think. 1.6 or 1.53, some around it will come. Is it S? Verify book and tell me. What is that? People are not at all responding. I don't know. So it will be there. So in this, when this is a white colors of light is passing, when the white light is passing, this will be like, this is what it is. But in the different colors of light is passing, in that again refractive index will be minimum to maximum based upon the colors of light. If the violet is passing, violet light is having the least speed in the glass, so it will show the maximum bending. That is why the speed is minimum, so the refractive index is maximum for violet light. Red color refractive index is minimum. Please note it down. This is a very important point. Now have you noted the diagram also? Everybody clear? All of you? Anything doubt? Anybody can ask. So such an important question it is. So justify your answer means any one point you can write. We can answer so many points. You can say through the glass, violet light is having the minimum speed so that it will be maximum bending. That's all your answer. That is also speaking the same meaning. So that is how you have to understand the question and you have to write it. So unless you know the dispersion of light through the prism, same concept we have to apply here. So in dispersion of light, violet light will be bending maximum and red light will be bending minimum. So the same concept here we apply. So that closest to the lens is deviating, converging violet light. That's all is the answer. Clear? Any doubt? Maitreyan, Monish, anyone having doubt you can ask. Mr. Rahul, Raja Gagan. Okay, so if people are not ready, what else I can do? That's fine. Next, question number 12. So please read very, very carefully and you have to answer it also very perfect manner, because this question is how many mark question? Check it here. 3 mark. So at least 3 points you should be there. So let us see. Smith, what is her name? Smriti is looking at herself in a convex mirror. So convex mirror means by this time, mind so many things you might be getting. What does this convex mirror means? Always erect
and diminished.
Diminished image. Very good. Museum standing 2 meters away from the mirror. So standing 2 meters away from the mirror means what is the object distance? minus 2 meters.
2 meter.
Understanding? Her image appears to be around half of her actual height. Means what is the magnification? 1 by 2.
1 by 2
Plus or minus? Anybody fastly? Plus or minus?
Plus.
Plus. Why? Because what mirror it is? Convex mirror. Virtual image. So always positive. So estimate the focal length of the mirror. Estimate the focal length of the mirror. That is what it is. So now let us see. It's very simple question. So as we know, identifying the object distance. How much it is? How much object distance? Minus. For this one, you people will get half mark. Half mark. Do you understand, everybody? Next, finding out the magnification. If you'll notice it, as we know that it will get a remaining half mark. Now let us find what is the focal length. Okay. So now, if you'll notice the focal length using the lens formula, we have to use lens formula. Now using let us see how it will be happening. So if we'll take magnification is equals to formula, it is mirror, correct? Sorry, mirror formula, not lens formula. So what is the mirror formula? 1 by f is equals to 1 by, all of you, 1 by
minus 1 by u.
1 by v minus of 1 by u. Now we can find, we know the magnification and we know the object distance. We can find the image distance. Can you find anybody image distance fast and tell me? Everybody. So magnification means we know the formula. Hey, I think here plus correct, Rahel Mukesh. You said minus?
Yes, sir. Mirror formula.
Sir, plus only, sir.
Be careful. That is what? Minus of v by u, minus of v by u, which is equals to m. So now if you'll do it, here no space, but I am trying to do. You all should solve. Mark it, question number, page number, and answer alone you solve. Okay. So now substitute formula, everybody. So what will come? Magnification is equals to 1 by 2, which is equals to minus of v, we have to find. Object distance is how much? Also minus 2. So this minus will get cancelled. This 2 will come this side. So v is equals to 1 by 2 into 2. 2 will get cancelled. So v is equals to, how much will come, guys?
1 meter.
1 meter. So positive,
F equal to 2v.
positive or negative, anybody can tell? This question you should tell me before itself. V is always will come positive or negative. Convex mirror.
Positive.
Positive. It will form at what coordinate? Object is at this coordinate. Image will form at first coordinate. Is it yes? All of you. So always image distance is positive. How much you got? 1 meter. So for this one, you people will be awarded another half mark. Do you understand, everybody? So now you have to find, sorry, this is totally 3 mark, correct? So finding the object distance half mark and finding this image distance is 1 mark. Totally how many mark is completed? How many mark is completed? 1 mark. Now you find the focal length. So substitute in the formula and tell me fastly. So 1 by f is equals to, v means 1 plus object distance is minus 2. Now tell me, focal length will come positive or negative? That is what my first question from you all people. Positive or negative?
Positive.
Positive.
That is, if you are able to make, your answer will be all right. So solve it you all. Before you have to solve it and tell me. So as we know, here will come. So 1 by f is equals to, you solve down. So as we know, I will take one as 2 is the LCM. So here you see plus into minus, what will come? Plus into minus 2 minus 1, which is equals to 1 by 2. Reverse, f is equals to how much, guys?
2 meter.
2 meter.
2 meters.
So now tell me, focal length is positive or negative for convex mirror?
Positive.
Positive. So you'll get answer is how much?
Plus
Plus
2
2
meter.
meter.
Plus 2 meters. So for this 1.5 mark we'll get. So totally how many marks will come? 3 mark question it is. So it's very simple question. It's not at all even our level. So, but of course you can see that how they are asking. So make it happen, work out and solve it. Then we'll move to the next question. Any different questions are coming, please kindly focus on it and you have to learn it. That is what I can say. Completed, everybody? Here, there is no space I am solving, but your notebooks you have to solve. Now also, if you are not solving, nobody can help you. I am saying, Mr. Ramanujam, have you solved? Mr. Pawan, Sai Karthik, Alana, find everything. Mr. Joel, I will check your answers. You solved or not? Show me the notebooks when you meet me. Mark the question number and solve it. Completed, everybody? Next, read the next question. So this question is A, B, C, D. So three points are there. 3 mark question. So all of you read the question, everybody. Yes, please. Read the question. A human eye, the distance between the lens and the retina is 17 mm. 17 mm means 17 millimeters. So now the question is, distance between the lens and the retina is 17 mm. The light entering the eye gets refracted at the cornea and then it at the lens. As I told you, cornea only 70% of light will be refracted and then it will be falls on the lens. Now, ciliary muscles in the eye cannot control the focal length of the lens by changing its shape. Do you understand, everybody? Means ciliary muscles are not functioning. So observe very carefully. The distance between the lens and the retina is 17 mm. So if you have taken lens, our human eye, this is the lens and this is the retina. So lens and the retina is 17 mm. Okay. Now tell me, is it object distance or image distance? Anybody?
Image distance.
Image distance.
That is very, very important. Okay. Sorry, they can control, they are saying, cannot control. Ciliary muscles in the eye can control, not cannot. If it is cannot, means it is a normal eye or defected eye. Anybody?
Defect.
Defected
Defected
eye.
eye.
Saying can control means, is it a normal eye or a defected eye?
Normal eye.
Because whenever people can read this question, they'll think that it is a defect of vision. So already this year sample paper, one numerical we solved. Do you remember that? Power magnification 6 came. Yes, Almukil? Kevin? Yeah. So yeah. Do you remember that, everybody?
Sure.
Yeah, if you consider as a defect of vision, we'll get magnification is 0.6. But if you consider as it's a normal eye, the answer is coming 6 dioptries. So difference, you have to identify whether it is a defect or not first. Now ciliary muscles are controlled, so it is a normal eye. Now tell me, they're saying that Diana is looking at the moon. What is the focal length of the combination of cornea and the lens in Diana's eye at this time? Anybody? All of you? What is the focal length? Diana is looking at the moon. What is the focal length of the combination of cornea and the lens in Diana's eyes at this time? Anyone?
Sir, U is infinity.
Object is a yes.
17 mm, sir.
Very good. What is the answer? By
17 mm.
answer should say, guys. What else is remaining, Ra? Everybody. Answer is what?
17 mm.
17 mm.
mm only. Who else said? Who is that? First, who said? Mukesh, I think. Is it?
Sir.
Who said the answer? What is the answer? Everybody, you consider object distance is infinity. Then what else will come? Focal length. Apply the formula, lens formula. What is the lens formula? 1 by f is equals to 1 by v minus 1 by
1 by u.
1 by u. So we know that u is equals to what? Girls, what are you doing?
Infinity.
I don't know what you people will think about you people. Be normal. Don't think too much unnecessary situations. As we know that moon means what? Object is at infinity distance. So 1 by infinity means what? What is 1 by infinity? 0. Do you understand?
0.
So this term will be deleted. Now 1 by f is equals to 1 by u. U is equals to what? Plus or minus? U is equals
Sir,
to
V, sir.
it's always plus. Check it, everybody. It's behind. Behind is plus or minus. Everybody. Even I told you human eye. What is the specialty of human eye? Wherever the object, image distance, is it possible to change? Everybody? Is it possible to change the image distance in human eye? I'm asking.
No, sir.
Answer to my question. I am seeing the near object, I am seeing the far object, I am seeing the very far object. Is it possible to change the distance between my retina and my lens? Anybody?
No, sir.
No, sir.
In our normal lens, artificial lens or man-made lens, object distance and image distance will definitely varies. If object is moving far or near, image also will varies far or near. But human eye, what is the specialty? Lens cannot be, that distance between the lens and the retina cannot varies. But who can varies? Everyone? Who can vary? Thickness. Thickness of the lens can vary so that it will adjust the focal length. It will adjust the power of the lens, but always the image distance is what? Always the image distance is what? Remains same. That is the point you should note down. So now 2 points I will say, listen. In man-made lens, focal length is remains constant. Who else will change us? Image distance and object distance. But in human eye, image distance is remains constant. Who else will change? Who else will change? Focal length and object distance. Please note down that. So 1 by V is equals to 17 mm. So now reverse if you have done, F is equals to also what will come? All of you. Focal length is also 17 mm. Make it fast. You have to solve. If not solving, you will never get the mark. So if you write 17 mm, if you will find for this question, you will get just half mark. Next. Dana is reading a book kept at a distance of 20 centimeters from her eye. What is the focal length of the combination of the cornea and the lens in Dana's eye at the same time? Now tell me, anybody? He kept at the
15.6 millimeter.
Yes, everything? Yeah, please. Answer, please.
Sir, 15.6 millimeter.
Is it correct? Check it once. Any others? Check it. This is in centimeter and this is in millimeter. You must convert it into. Either it is centimeter or millimeter. You just decide. Let me take this is 1.7 centimeter. Then you substitute it. Answer, please. Or else you take it into this is as a millimeter and tell me the answer. I want the response from everybody. I will solve it in the another thing. Here is no space, so you can solve. Now again we have to find the same thing, focal length only. Now you can take object distance is minus or plus. Anyone? Object distance is minus or plus. Now check it here. Reading a book that kept at 20 centimeter. So object distance is minus 20 centimeter, means in the sense of minus 200 millimeter, because we know that 1 centimeter equals how many millimeters?
10 millimeter.
And object image distance is still positive, 17 mm. So please solve it and tell me the focal length. Who will tell me first? I will see. I will solve it.
15.6 millimeters.
Is it correct? 15 or 18? I want response. Check it and tell me. How much it will come, Ra? So 1 by 17 plus 1 by minus 200. So now it will come 1 by 17 minus of 1 by 200. Let me take the 200 is the LCM. So 200 you cannot take the LCM. You can take 17 into 200 multiply. So do it, everybody. I want the answer, Maitriyan, Laksha.
15.6 only.
15.6 only coming. So if you take 17 into 2, it will come 3,400. So here will come 200 and here it will come 17. So now if you do 200 minus 17, it will come around 183 divided by 3,400. So reciprocal if you do
Sir,
3,000.
length formula, sir. We have to add, sir.
Which one?
17 and 200.
Which one?
17 and 200.
Huh?
Sir, 1 by V minus 1 by U, sir. Minus 200, sir.
It will become plus, correct? It will become, yes, very good. So 200 plus 17. Is it yes, Rudreshwar? 217 will come.
Yes, sir.
Yeah. So very good. So 217 divided by 3,400. Is it yes? So reverse. 3,400 divided by 217. If you solve that, you will get 15 point, how much?
6 millimeter.
Yeah, 15.6 millimeters. Good. So that is the answer. All of you solve it.